Welcome back once again. This is Nick Aguirre. Trigonometric identities. This is just an introduction, and then I will go further and more complicated. Even odd identities. For example, if I'm going to show tangent negative, here it is. For example, this is our theta, and here is our negative theta. You know that here tangent theta is equal to positive because it is in the first quadrant, but tangent negative theta is equal to negative because it is on the fourth quadrant. Tangent is only positive on the first quadrant and on the third quadrant. That's the reason why. The same is true with sine. So we have sine theta, that is the first quadrant, sine negative theta, that is on the fourth quadrant, then we have negative. That's negative. Sorry if I put that. I didn't. I should put positive there. But as you can see here, cosine and secant, we have cosine theta is equal to positive because it is in the first quadrant, and cosine negative theta is also positive on the fourth quadrant. I forgot to tell you that sine is only positive in the upper quadrants, the first and second quadrant, and cosine is only positive in the right quadrants, the first and the fourth quadrant. That's why it doesn't matter for cosine if you take the negative or the positive. It's the same value. Okay? But it is not the same with tangent and sine and their reciprocals. Okay, some more identities. Reciprocal identities. Sine, that is cosecant. And we have cosine, we have secant, tangent, and cotangent. And vice versa there. Another identities that we need to know is the quotient identities. I will show you briefly here. For example, we have this unit circle, and we have this is our x and y, this point. So this is y, this is x, and we have 1 there. So we have cosine theta is equal to the adjacent side, x, divided by 1, of course. But sine theta is equal to y. And tangent, we have the opposite side, y, divided by the adjacent side, x. And we know that y is equal to sine theta. And x is cosine theta. So tangent theta, is equal to sine theta over cosine theta. And cotangent is the reciprocal. That's why you got the reciprocal here also. Okay, another identities that I want to discuss is by using this triangle. Okay, if this is 60 and this is 30 degrees, we know that this is 2, 1, and the square root of 3. Okay, I've used this before, so I hope you remember. So if I have cosine 60 degrees, that is 1/2 adjacent side divided by the hypotenuse. As you can see here, that is also equal to sine 30 degrees. And if we have cosine 30 degrees is equal to, that is square root of 3 divided by 2. And that is also sine 60 degrees. Now if we're going to generalize that, we have cosine pi or 90. We can start with 90 first. 90 degrees minus 30 degrees is equal to sine 30 degrees. And sine 90 degrees minus 30 degrees is equal to cosine 30 degrees. So if we take a variable of this, we have cosine 90 degrees minus theta is equal to sine theta, or sine 90 degrees minus theta is equal to cosine theta. So remember this. It can be written also as cosine pi over 2 minus theta is equal to sine theta. And sine pi over 2 minus theta is equal to cosine theta. Okay? More identities. Trigonometric identities, the Pythagorean identities. Okay. How do we know this? Okay, Pythagorean says that if we have x squared plus y squared is equal to the hypotenuse, and we know that x cosine theta is equal to x and sine theta is equal to y. So we have cosine squared x plus sine squared x theta is equal to 1. Rearranging them, I don't know why, but you can write this way, it doesn't matter. But if you want to rearrange according to this, it is also alright. But because we have x squared plus y squared is equal to 1. From this, if we subtract both sides of the equation by sine squared theta, sine, then we have cosine squared theta is equal to 1 minus sine squared theta. And we know from algebra, this is the difference of two squares. Then we have 1 minus sine theta, and then 1 plus sine theta. Okay? And then if we divide both sides of the equation by, if I'm going to use it here now. Oh, another is, if we subtract both sides of the equation by cosine, then we have sine squared theta is equal to 1 minus cosine squared theta. That's another. So this one and this one. You can also use the difference of two squares. Okay. But if we're going to, for example, divide both sides of the equation by cosine theta, squared theta, sorry, then this will become tangent, and this will become 1, and this, cosine theta, this will become secant. Okay, because we have the reciprocal identities. So 1 divided by cosine is secant. There you go. Okay, and the same principle for this one. If we divide both sides of the equation or all the terms of the equation by sine instead, then we will get this identity. Okay, and in my next video I will be discussing some examples about the identities that I discussed, and I hope to see you in my next video also. Have a nice day. Thank you for watching.